Okay, week 2 or session 2, confusion matrix. So we know we have a win and loss like from last week, but we want to denote a win and loss as a positive or a negative. Positive or negative. All right. And so in terms of the outcomes, we're really interested in the win. And that's kind of important in terms of at least understanding how, when you go deeper into the machine learning algorithm, the level of interest. Okay. From there, we have a positive, negative. Okay, yeah, win or loss. And that circle denotes the machine learning algorithm. So the machine learning algorithm, anything outside is going to be denoted as a loss. Anything inside is going to be denoted as a win. So what's happening here is that this is a mistake. Okay, this is a mistake, and this is a mistake. Okay, whereas this is correct and this is correct. So let's actually denote these regions. Let's denote these regions as region 1, 2, 3, and 4. Region 1 is when you're saying that it's in reality it's a win, but outside of the circle it's a loss. So that's an issue. That's incorrect. And in region 2, you're saying that it's a win because it's inside the circle, but in reality it's a win, so therefore that's correct. Region 3, you're saying that it is a win, but in reality it's a loss, so that's incorrect. And then finally, region 4 is saying that it is a loss, but in reality it is a loss. That's correct. So how we denote this in this capacity is to say that region 1 is a false negative. Okay, you're saying that it's not a win. You're saying that it's not a win, but in reality is it a win. Whereas in region 2, you're saying that it is a win. In reality, it is a win, so therefore it's a true positive. It's true positive. Region 3 is saying that it is a win, but it's not really a win. That's going to be called a false positive. Okay, it's a false signal. Okay, false positive. And last but not least, a true negative is when you're saying that it's a loss. In reality, it is a loss. Okay, so let's actually make up examples. Let's make up example. So this example looks like this. All right, so here what we're doing is we're turning this information that we gathered in this display and putting it into, I'll call it a table, or for machine learning algorithmists, I guess that's the word, or people that study machine learning, you call this a confusion matrix. So on the cross diagonal, the 5 and 6 are the actually accurate count. So here it's the 2 and the 4. So this column, this region here, 5 is the 2. Outside here, this 4 is the 6 if you count the points. Whereas 8 is going to be when you say you predicted it as a win, but in reality it's a loss. So this is the 8, and you predicted it to be based off the machine learning algorithm to be a win, a loss, but in reality it's a win. Okay, so what we can do, there's certain measurements that we're interested in terms of this confusion matrix. One of the first measurements is when we consider, given that it's classified as a win. All right, so when I say given it's classified that it's a win by the algorithm, that's this row. Okay, so that's 14. Our denominator is 14. What's the probability that's actually a win? Okay, take a moment to think about that. It's going to be 5 over 14. That 5 over 14 has a special name. It's called precision. Okay, it's called precision. How precise are we in terms of our algorithm? And last but not least, okay, given that it's a true win, so we're looking at this column here, given that it's a true win, what's the probability that it's an actual win? That's going to be 5 over 14. Okay, 5 over 14. And that's called a recall. What's the algorithm's ability to recall what's actually true in terms of the win? Okay, so that's it for this video. A little long. It's fine.